Question 9, which atom contains the most neutrons? So let's go to periodic table and just fill in the bottom number for it. So for chromium, Cr, the bottom number is 24. For manganese, Mn, is 25. For iron, 26. And for nickel, it's 28. And then you just subtract them. So top number minus bottom number, 54 minus 24, 30 neutrons. 55 minus 25, and 30 neutrons, so it can't be A or B because it says most neutrons. And then 57 minus 26, 31 neutrons, and 58 minus 28, that is 30 neutrons. So the answer is C, that contains the most neutrons. Which suggestion improves the accuracy of the titers? Student completes a titration to determine the concentration of ethanoic acid in vinegar. 25 centimeters cubed of vinegar are transferred to a conical flask using a pipette. A few drops of phenolphthalein are added to the conical flask. Sodium hydroxide solution is added from a burette to the conical flask. Titration is repeated until concordant results are obtained, which suggestion improves the accuracy of the titers. Rinse the conical flask with vinegar between each titration. Rinse the conical flask with sodium hydroxide solution between each titration. Rinse the conical flask with water between each titration. Definitely, that will definitely improve accuracy of titers. They repeat this question. I'm pretty sure this is a repeat question as well. I'm not rinsing a conical flask, but that won't improve the accuracy of titers. Which suggestion decreases the percentage uncertainty in the mean titer? Okay, use a more dilute solution of sodium hydroxide in a burette. Yeah, we've got a bigger solution. It's going to bigger sample size in this case. More dilute solution of sodium hydroxide is going to decrease percentage uncertainty. Which reaction has the highest percentage atomic economy for the production of hydrogen? This one's a bit of a weird question. Never seen this before. But until now, percentage atomic economy. I saw this question like 10 minutes ago. Is atom of desired products over mR of desired products divided by mR of reactants times by 100. So of hydrogen, mR of hydrogen is 2 divided by mR of the reactants. So LiH plus H2O. Li 6.9 plus 1. So 6.9 plus 1 plus 2 plus 16. 1 divided by 25.9. 2 divided by 25.9 times by 100. 2 divided by carbon 12 plus 16 plus 2 plus 16. 2 divided by 46 times by 100. For B, 2. But because it's percentage atom economy, we do include the number of moles. So it's going to be 2 times by 3 divided by the reactants. Aluminium, 2 times by 27. 27 plus 27 plus 3 times by 18. 108 times by 100. One second, guys. 6 divided by 108 times by 100, then we should get 6 divided by 34 times by 100. Because 3 moles of hydrogen, 3 times 2 divided by 34 times by 100. And you should get D as the highest percentage atom economy for the production of hydrogen. So yeah, the tricky part is, I guess, remembering for percentage atom economy, include the moles and times mR by the moles when necessary. Question 13. Which molecule has a permanent dipole? NCl3. Nitrogen bonded to chlorine, chlorine, chlorine. But because nitrogen is in group 4, I have a lone pair of electrons. CCl4, that's completely symmetrical. PF5, phosphorus in group 5, bonded to 5 fluorine, that's also completely symmetrical. SF6, sulfur is in group 6, bonded to 6Fs fluorine. So yeah, NCl3 is the only molecule with a permanent dipole in this case. Which molecule can accept electron pair during the formation of coordinate bond? Silicon is in group 4, bonded to 4 hydrogens. Phosphorus, okay, so it's not NH3. You know, it looks like it could be NH3, but it's actually not. That doesn't accept any electron pair during the formation of a coordinate bond. And aluminium can, so it's AlCl3. Question 15. Which reaction has an enthalpy change equal to standard enthalpy of formation of potassium oxide? Already I can cancel out C because that's with ions, and standard enthalpy formation is standard elements, no ions. What else can I see? It's also not going to be A, since we're forming 2 moles, forming 1 mole. So it's either B or D. Whereas if you look at B, it's just O by itself. That's also wrong. It should be O2, half O2. So that D is the correct answer. That one's definitely a lot trickier compared to the previous ones I've done. But yeah, cancel out C, so you've only got 3 options left. Cancel out A because you know the definition, you form 1 mole of the compound. And then so it's B and D, and then B, well, needs O2, it's oxygen. So then that form must be D. In which species is chlorine in its highest oxidation state? If you look here, ClF2, F2, so minus 2 is going to be plus 1 in this case, minus 8 plus 7, yeah, so the answer is going to be B already. I don't need to really calculate the rest because, yeah, there's no way that they can be greater than 7. The answer is B. Which statement about this redox reaction is correct? SN2 plus oxidizing agent, and it gains electrons. SN2 plus is a reducing agent and it gains electrons. SN2 plus is an oxidizing agent or reducing agent. No, none of these two. SN2 plus is not oxidizing agent or reducing agent. It's potassium Cr2O72 minus. And it is the oxidizing agent and it does gain electrons. So the answer is C. Question 18. Which incomplete half equation is balanced by adding 2 H plus signs and 1 electron to the left hand side? It has to be B, because that's the only one we've got charges on iron. Like, think about it. If I add 2 H pluses and 1 electron to the left hand side for A, well then I'll have 2 H plus E minus, so I'll have a plus 1 charge on the left hand side, and all of these don't have any charges on the right hand side, so it just wouldn't be correct. So the answer is B, and it makes sense. If you have FeO2 plus, you add 2 H pluses, you add an electron, we have V3 plus H2O, and the charges balance out. Use the information table to answer questions 19 to 23. Which solution contains carbonate ions? Add a few drops of H2SO4. Okay, yeah, that was really easy. It's Q, solution Q, pure fact. Effervescence, bubbling. This one's effervescence and white precipitate. Yeah, that's not what we want. What could be the identity of the compound in solution P? Solution P, what could be the identity of a compound in solution P? Now I know it gives a white precipitate with H2SO4, ferric acid, cream precipitate with HNO3, nitric acid and silver nitrate, cream precipitate, no visible change with that, and orange solution with chlorine. Orange solution with chlorine. Just from the ideas white precipitate with H2SO4, it's going to have to be a barium, something. And because it also, orange solution is going to be BaBr2. What observation is expected in test 2 for solution S? Test 2, solution S, the expected observation. Well, it has white precipitate with H2SO4 ferric acid, no visible change with that, and a few drops of chlorine and the dark brown solution. So it's going to be iodine, so it's going to be pale yellow precipitate. In test 2, the mixture is formed by solution S is filtered, which substance is present in the filtrate. And it says, I'm asking, question was discounted due to a typographical error in option B. Mixture formed by solution S, but the answer is that AgI, silver iodide. What could be the identity of a compound in solution T? No visible change, white precipitate, no visible change. What are the options? Manganese, MgCl2, BaCl2, BaBr2, MgBr2, MgCl2, MgCl2. You can clearly see from test 1 there's no visible change, no white precipitate, so Ba, any barium sulfates, MgCl2, MgBr2, no visible change, a few drops of Cl2, white precipitate with NaOH, white precipitate with HNO3, few drops of that. It's going to be MgCl2, not MgBr2. And that is the end of the multiple choice questions.